Hello, and welcome to the shop. My name is Brian, and today I'm going to be talking about MeterMatch, which is used to make gauges more accurate. It's a small unit that we manufacture and design here in the United States, and everything I'll be talking about is in the instruction manual that will come with your unit, and is also available online if you decide you'd like to take a look at it prior to purchase. MeterMatch is made for gauges that use resistive senders. And most often that's fuel gauges, but it can also include others such as oil pressure gauges and temperature gauges. The little demonstration setup that we're going to be using today, this is our little car, includes an ignition switch coming from the battery. We have an arbitrary fuel gauge here. And here's a fuel tank sender, which varies resistance as the float moves up and down, as does the level of fuel in your tank. So why do we need MeterMatch? Well, let's turn on our car and see what we've got here. We've got the fuel sender now clear at the bottom, which would normally be empty, but as you can see, the gauge reads full. When we move the sender to the top, that indicates a full tank, the gauge moves down to a quarter. So you can see that not only does the gauge move completely backwards, but it's off scale as well. So we're going to use MeterMatch to fix that problem and to make the gauge work properly. We have the unit already wired up here on our example bench, but what you need to do once you get a unit is remove a screw from the back of the enclosure, and that opens it up and gives you access to the inside of your unit. The wires are connected into this terminal strip, and then the switch and these buttons are used for calibrating the unit. The wires used for connection, we recommend 18 gauge, although you can use larger or smaller wire and it works fine electrically. But number 18 works fine with the terminal strip, and it's about right for the slots in the enclosure. If you use a larger wire, you may need to file those out a little bit more. So here we have the unit wired in. At the bottom pin here, we have 12 volts that switch. So it comes from the ignition switch. So it turns on and off with power, even though the unit uses very little power. Black wire for ground. The next wire is from the gauge, and the next wire is from the sender. You can envision these orange wires as originally going between the gauge and the sender directly. And what we've done is cut that wire in half so that the MeterMatch can read the sender with its internal ohmmeter, calculate what current it needs to drive the meter to the right place, and that comes out of the other wire, the other end of the orange wire. All right, so let's program our MeterMatch and see if we can make it work properly. The MeterMatch has 4 memory locations, or calibration points, and typically one is used at the high setting, like full, and one is used at the empty setting. And there are 2 more that you can use between those if you have a tank that has a step in it or cylindrical or needs the accuracy improved between empty and full. We will use points 1 and 4, which are high and low, and that's adequate for most installations that are done. So let's go ahead and calibrate the unit here. We'll turn the key on, and we've got the sender set to high, so that's typically switch position 1. So once we've got it in switch position 1, we'll look at the gauge and use the up and the down buttons to move the needle. As you can see, I can move it either direction. So I'll move it up to full, and then I push save, and you'll see the LED blink as it saves that in the computer's memory permanently. Okay, then we'll do the low point, so we'll move this to position 4, and we'll move our sender down to the bottom, and then we'll use our down switch. We can press and hold or individually kick it down to empty, and then we can push save again. And when we push save, it'll go out and measure the resistance of this, and measure the output here and remember that so we can do calculations in the future. Okay, then we'll go back to switch position 0 and it should work. So as you can see, we've got the sender down all the way to empty now. The gauge reads empty. We'll put it at full and you'll see the gauge goes up to full. So we've corrected the error in this gauge as far as the direction and how far it travels. We can, as I mentioned, we can also put in an intermediate point if we like. And I'll give you an example of that. Okay, you can see here, I've got the sender set to where half tank would be, but the gauge only reads a little bit over a quarter. So we'll use another calibration point. Let's use calibration point 2, although we could use 3 if we wanted. And here we'll leave the sender at half point. We'll move the gauge up to half. Push save. Okay, and then go back to the normal operating position, which is switch 1. Okay, now you can see it goes down to empty as it should, smoothly goes up to half point where it should be, and it finally goes up to full. So we've matched this gauge and this sender so that they're working properly. Next, we'll look at another technique for programming a unit. Okay, so we just calibrated it by letting our sender represent the values that we're going to see on the gauge. And while that works just fine, sometimes it's not all that easy to drain out your fuel, for example, or wait until you run out of fuel to set a low calibration point. So there's another way of doing this calibration without using the sender. Inside the instruction manual, on about page 5, you'll see a table that shows a number of preset values in the MeterMatch that you can choose. 0 ohms, 10 ohms, 33 ohms, and so on, which are standard values for most gauges. So we can tell a MeterMatch to use those numbers rather than reading the sender. So let me show you how you do that. The first thing I'm going to do is reset the unit just to get rid of all of our old calibration. In order to do that, you leave the switch position at 1, or at 0, I'm sorry. Hold down the save button and then apply power to the unit until it blinks. And that'll reset all of the calibration constants in the unit. You can reset individual calibration points by setting the switch, so let's say for example to 1, holding down the save and powering it up, and that'll erase just that 1 point. So you can redo it, or if you don't want to do it. So here we know we have 10 ohms at empty on this sender. We'll leave it in the middle. But according to the chart, that means that we need 2 button pushes. So in order to do that, we press and hold the save button and we push the up button. It blinked once, push it again, blink twice. Okay, so we've got 2, which represents 10 ohms. Then we go to the position we're going to calibrate, and again, that represents empty. So we'll use the buttons to make the gauge read empty. And save it. Okay, and then we know the gauge when it's at full is 180 ohms, which means that we need 6 blinks. So we'll set this back to 0, and then we'll push the up button until we get 6 blinks. One, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And there we are. Okay, then we'll go to position 1, and we'll use the buttons to make the gauge read full. Push save. Okay, now we'll go back to 0. And as you can see, now that it's in normal operating position, empty is correct down at 0. 180 ohms is correct up at full. And if we wanted to use that same technique to reset the middle point, we could. We could choose, for example, 90 ohms, which would be about half, and set the number of blinks for that, and then switch position 2 and calibrate that. So we've done our entire calibration without draining your tank or messing with your sender. While you're calibrating your MeterMatch, you may have noticed that when we're using the up and the down buttons to select a particular needle position, that it moves in relatively large steps, and this is to help speed up the calibration process. However, if you can't get the exact point that you need, we've provided so that the up and down increments are slightly different size, so by toggling back and forth between the up and the down buttons, you should be able to achieve any value. Next, I'd like to talk about the optional alarm feature on MeterMatch, how to install that and how to program it. The alarm LED is a way that you can get a blinking indicator that you can put near your gauge that if the reading is above or below a setting that you programmed into the unit, that the LED will flash and draw your attention to the gauge. You can use an LED that you purchase from us, or you can provide your own LED. Any standard LED should work. Here's the LED that we are currently providing. It's wired into the MeterMatch with the cathode of the LED connecting up to the alarm terminal of the terminal strip, which is pin 5, and 12 volts applied to the anode side of the LED, and we have that connected here in parallel with the 12 volts that's providing power to the MeterMatch. To program the LED indicator, we use the same switch that we used for calibrating the gauge, except instead of using positions 1 through 4, we use positions 5 and 6. And position 5 is to set the high limit, and position 6 is to set the low limit. So let's set the low limit using position 6 to show you how it works. Let's say in this case that we'd like the LED to start flashing when your fuel is less than 25%. So we'll set our gauge to 25%, push save, and then go back to position 0 on our rotary switch. Now you can see that as the gauge in the upper areas, there's no indication, but as we pass through 25%, the LED comes on and starts flashing. Then when we refill our tank and get above 25%, it stops. Let's reset that point and set a high limit. So in this case, we go back to position 6, remove power, press and hold save, and turn power back on. Now when we go back to position 0, we'll see that the alarm indicator doesn't go on anymore. So this time, let's set a high limit, in which case we use switch position 5. And this time we'll run our gauge up to 3/4 tank, push save, and then go back to position 0. Now you can see that as when we get above that point, that the LED starts flashing. Now this is probably of no use for fuel gauges, but if you're using the MeterMatch with a temperature gauge, you might find this useful to indicate to the driver that it's over a particular temperature. I might point out that most gauges work so that the up button makes the needle go up and the down go down, but some gauges don't. They work backwards from that. And if your gauge is backwards in that regard, then you should swap the high limit and the low limit alarms, because they'll work backwards unless you do that. So that's how to use the alarm indicator on MeterMatch. The next feature of MeterMatch I'd like to talk about is called voltage correction. Most cars use an instrument voltage regulator that provides a smooth 12 volts or 5 volts or 8 volts to your gauges all the time. And so the battery voltage doesn't make any difference in the reading of your gauges. But sometimes you'll run into a vehicle that the gauge reading will change with voltages. Let me show you as an example. Right now, we have our car at 12.5 volts, which is typical for a battery that's just sitting with the car not running, and our gauge reads 1/2. But then when you start up the car, it typically goes up to about 13.8 volts, and in some cases even up to 15 volts. So you can see now, if I crank up this voltage, you can see the gauge has moved about 1/8 of a needle, down here, back and forth. And so basically what would happen is when you start your car, that the voltage would go up and your meter reading would change. So you can fix that with the voltage correction factor on MeterMatch. The correction is turned on and off by removing power. And if you want to have the switch at 0, to turn voltage correction on, you press and hold the up button, then apply power until the LED blinks, and now it's turned on. You can turn it off with the same sequence, only this time you press and hold the down button, and that turns voltage correction off. Okay, so in this case, you can see that now, even though I change the voltage from the battery, the gauge stays rock solid, and that's what we want. And you can find out, just experiment with this. If your car moves, when the gauge moves when you start it up, turn it off or turn it on, whatever it takes to make it work properly. The next MeterMatch feature I'd like to talk about is called reading averaging. You may have noticed that the needle moves relatively slowly on the gauge as we've been programming it, but we've artificially done that. We slowed down the needle so that when fuel splashes around in your fuel tank, the needle in your gauge doesn't swing wildly back and forth. A lot of gauges have built-in damping, particularly the older gauges and some of the higher quality new gauges, so they won't move fast regardless. But in some cases, you might want the gauge to move quicker if the gauge is capable of that. And so you can turn reading averaging on and off. So I'll show you how to do that. First, let me show you here how in the default mode, when you get the unit, it moves slow because reading averaging is turned on. But to turn it off, we remove power from the unit and set the switch to position 7, then hold down the down and save buttons and then apply power to the unit. Then when we go back to normal position 0 on the rotary switch, you'll see that the gauge moves very rapidly. So you may wish to do that in some cases. It's simply a toggle, so if you want to go back to the default mode, just do exactly the same sequence again. Set it to 7, hold down and save, apply power, go back to position 0, and now you can see that the gauge is moving slowly again. So that's how you use reading averaging in MeterMatch. I've shown you the most common technique for programming the MeterMatch, but there are a couple other possibilities. One is that we have some presets built into the MeterMatch for common applications. For example, we have a preset for MeterMatch for most of the early 70s gauges and 80s gauges that use 73 ohms for empty and 10 ohms for full. And this was common for some of the Mopars and the Fords and AMCs as well. And this allows you to get to a close value, and then you can go back and fine tune if you like. In order to do that, you program one of those fixed values. We find the value from the chart in the instruction manual, which in this case is 3. And to program that, we set the rotary switch to 3, power off, hold down, save and up, and apply power. Then when we go back to position 0, it'll be calibrated quite close for the vehicles that are listed in the book. Then you can go back and fine tune it as need be. Another way you can program the meter match, if you know the values of your sender, is that you can replace your sender with a resistor, and that will represent what the sender would. So you can buy resistors, for example, that would represent the low limit of your sender and the high limit. And that can be anything from just basic resistors that you get at Radio Shack or online at places like DigiKey. Or if you have a potentiometer around, you can connect that to your digital multimeter, measuring the resistance, set that to the resistance value that you want, replace your sender with that, do your calibration, and you don't need to add or remove fuel from your fuel tank when you do that. Thank you for watching the video. It's been my pleasure to tell you about MeterMatch.